Let us shift to the second paper by Mr. S.G. Athawale. He is going to make presentation on heat and mass balance case study of sugar plant. The brief introduction of the speaker. He is a B mechanical and member of Institute of Engineers. He has boiler proficiency and he is chartered engineer. From 1969 to 85, he worked with Mr. Godavari Sugar Mills, Sakrawadi in various capacities. As a chief engineer, cum factory manager for 8 years he served. He was responsible for planning and erection of Somaya Sugar Works Samirwadi, one of the modern plants. From 1986 to 90, worked as a technical director with Mr. Crushwell Engineers Private Limited, Pune. As a technical director, he was responsible for marketing, design, rescheduling, manufacture of various sugar mill machinery during this period. He has also worked as a consultant to some sugar factories for design of machinery and proposing modernization of plant. Since 1989, formed a partnership firm Accents Engineers for consulting and erection of sugar factories. He was responsible for erection of 6 new sugar plants, and he had rendered consultancy services to many sugar factories. I request Mr. Athawale to start his presentation.
Guru Brahma, Guru Vishnu, Guru Devo Maheshwara, Guru Sakshat Parbrahma, Tasmai Sri Gurave Namaha. Distinguished guests and my fellow delegates, whatever you have heard up till now regarding mass and heat balance or something, it was useful as a knowledge as to how the developments are to take place. My contention when I was asked to present this paper was that to help the sugar factory personnel as to how the heat and the mass balance can be calculated. The various aspects that our chief guest and Mr. Gharpure said are more to the broader view of the sugar industry or the industry in particular. How does it help a working engineer or a chemist in calculating or designing an equipment by means of heat and mass balance? What I am presenting today is an exercise that we did some time back when we were trying to chalk out new specifications or the advanced specifications for a standard sugar factory of 5,000 ton. You know, the developments since the last specifications have been tremendous. As our Mr. Bhatt Sahib had already said, that the steam consumption had come down from 55% to 25, 30%. The recoveries have increased from 10 to 12, 13, 14. So all these things needed to be incorporated in the specification because everybody who is coming to the sugar factory doesn't know all these things. There are many experienced persons in this audience who have the knowledge of heat and mass balance, who might have done the heat and mass balances in their own factories, who might have used those heat and mass balances practices in designing the equipment. But for those who might not have the general knowledge about the heat and mass balance, this exercise we had done for a new sugar factory may come as a useful tool to them. Remember, this heat and mass balance that we have done is not foolproof. We have taken a macro analysis of the mass and the heat. If we go into the details, there will be some another things that can be added into those. And to calculate the equipment that may be required for a efficient as well as a energy economical factory, a number of permutations and combinations were done by us. Because as you know, the heat balance is generally dependent on the system that you provide in your evaporators and the bleeding system that you provide. We had to presume, because we didn't have the analytical data to as a base. So we had to presume some criteria on which the whole heat and mass balance can be developed and designed. So this sheet shows the data that we have assumed, like 230 tons of cane and 5% and all those things. What heat and mass balance that we are calculating is a calculation. The basic concept is material is not destroyed. Whatever comes in goes out. Either it is converted into another mass or is converted into energy. Similarly, energy is also not destroyed. It transforms itself into one, gets or some losses there. For any process, some energy is required, and that is what I will be showing in the next slides. For determining the heat balance, the major portion is what is the heat consumed in various places. There are 3 stations where the heat is consumed for evaporation and for heating. That is juice heating, the lime juice heating, all types of juice heating, and the pan floor crystallization. And all these vapor or the steam or heat that is coming is from the evaporator station. Because the basic structure is that you are evaporating the water from the juice and crystallizing it. Previously, when we were not following the proper systems or bleeding systems, the steam consumption used to be around 55%. Major was the consumption on your pan floor. Now, as many of you must have seen that factory also, the Venkateshwar sugar factory, they have developed the system, or they have adopted and followed the system where the steam consumption has come down to below 30. Why? Number one, is their pan floor requirement of steam has gone down, or we can bring down by certain practices that we follow, and by adopting a bleeding system, so that all this steam that is required at the heating medium or the pan is coming from the lateral bodies of the evaporator. So all these things were to be considered while we are designing the equipment. The first thing was to find out the solid balance. You know the total solids that come from the cane, and then the total solids that go out of the sugar factory. Those solid balances were to be first designed. That solid balance gave me the primary requirement of steam for crystallization, that is at pan floor. दोन नंबर दे. No, this is the दोन number. Now, these are the calculations. I mean, what I want to show is these are the calculations, but the basic thing is that by assuming the various data that running sugar factory has there in their, but for a designer, these data are assumed. I calculated the next slide. I mean, go ahead. नाही पॉइंटर जाऊ दे मला फक्त स्लाइड हे करा त्याची this one and the next one. From the total solids that are being transferred from one end to another, I calculated the masket percent, the masket, the ingredients, and then I tried to find out how much evaporation needs to be done at the plant floor. actual theoretical evaporation. Now, what happens in practice is that although the solid balance is going to be the same, the use of water in number of places, that is in melting or in preparation of magma or movement water or washings, that plays a very important part in your energy consumption or the heat consumption at the plant floor. So after the calculation of the next, yes. This is the solid balance that I have calculated. Next sheet, next slide. And this is the sum total of the purities of various fluids and the Brixes are assumed, that are shown in the yellow stage. And from that, we have calculated the total quantity for a 5,000 ton, 230 tons per hour cane crushing and the percentage on it. Now with this, next slide, this is the way we calculated the total evaporation required for various mass kits. These are theoretical. Again, this is the minimum that will be required for evaporation at the pan floor, and this is the basis for our evaporator station or the heat balance program. Now next slide, next sheet. Third. Now, while working the energy balance or the mass balance, what we have to do is, I mean, the mass balance as a total sugar factory, but I divided it into number of units, like each juice heater, evaporator body, pan floor, and other things, and calculated the input mass and the input energy to each block, and output energy and output mass of each block. The total of all these blocks becomes the total heat and mass balance of the head. Next slide. Next slide. Go ahead. This is the block. This is block wise. I mean, pan, vapor line, juice heater, or the incoming raw juice and vapors and outgoing raw juice and vapors, they are balanced. That way, the energy is also balanced and the material balancing also done. This is done in various equipment. I mean, all the equipments like clarifier, filter, evaporator, each evaporator body, then the boiling house, condenser, and then with such a type of analysis, it was possible to work out what is the final steam consumption in the sugar factory. And that final steam consumption was coming out to about 25% on cane. Now, in this sheet, you can see that I have not taken the losses in many of the equipment, because those cannot be measured or calculated. They are to be either assumed or neglected. Next sheet. Now this is the next sheet. Hold on. Now after all these calculations, I mean, these calculations you all must be doing at a regular basis. Only thing is that I made a program, an Excel sheet, and put all those calculations there. And this is the summary of the calculations that I have done. Remember, I have taken only the sugar factory into consideration. I have not gone into the byproducts or the what can be done with the other, so that the sugar factory will be profitable or not. This is only as a base of white sugar manufacturing that I have taken into consideration. This is the material balance for cane, and input will be cane and the lime, and output sugar, molasses, press mud, bagasse, vapors going to condenser, and surplus water that is going to the tanks. This is the material balance for total sugar factory. Next slide. Then this is the solid balance. Solid means all the solid, that is sugar, non-sugars and the ash. How that is lime you add, I have not taken into consideration the sulfur dioxide or the phosphoric acid because those quantities are little less and it would be more complicated. The output is sugar. All these figures are from the calculations that I have shown earlier. Next slide. Similar to side, I have also worked out the water balance. And next slide is the energy balance. Now this is the energy that is input. This is the bagasse used for process, rest of the bagasse goes for saving. This is the mixed juice that comes into the process. And this is the total energy that is input, that is in megajoules per hour. Next slide. This is the output, that is output is sugar, output is molasses, then output is electrical power in the turbines, vapor going to condenser, and the surplus condensate that goes. Each has an energy. At a particular temperature, all these temperatures are mentioned, and the energy is given. This is the energy that is output. Next slide. These are the losses that occur during the process. That is loss in boiler, turbo generator, clarifier, and some of the losses that I had not considered may be there. So these are the total losses and the energy actually consumed. Next slide. This will be the total energy input, total output, and these are the losses. The energy utilized for manufacture is about 345 million joules per ton of cane, or taking consideration of electrical energy used also, because I am talking about only heat energy. Taking electrical energy also consideration, this figure will be about 442.3. Previously, these figures, as you can find out from internet also, 900 megajoules was a figure that used to be common for conversion of cane to sugar. Now with the advanced technologies or what I have described in our sheets, the steam consumption reduces, so the total energy consumed. Now what we can do, I mean, we are talking about efficiency. The energy that is lost, the energy losses in the process, those if you can control and if you can reduce, then either the energy input reduces or the energy utilized per ton of cane will reduce. Those are the two things that will happen. Now it is for all of you, I mean, this is not a educational lecture for your kind information. This is what we have done. There may be some errors, there may be some missing things, and I would be very glad if our knowledgeable persons can point out that these are the things missing, so that when we are finalizing the things, those things can be incorporated. But this is the way we will have to go. You will have to consider each unit as a block, consider the input and energy, input of mass, output of energy and output of block. And then in total, you will have to consider the total sugar plant. I hope I am not taking much of your time, and I hope this will be a little use to you, and I welcome suggestions from you. Thank you.
Now, house is open for interactions. Any question, expert opinion? Okay. Although this is a very studious presentation by Mr. Athawale, I have got two observations. Okay. First, in your solid mass balance, You have mentioned sugars and non-sugars and ash. Along with ash, there was also clinker. Okay, quite long back, clinker formation was there. And now, ever since preparatory index has increased from 85% to 92%, clinker formation has been reduced a little bit less, but it has got its accountability. So, what is the accountability of that clinker? Okay.
The ash I am talking about is the inorganic material that is called ash. It's not there. I mean, the sugar, non-sugars are the derivatives of sugar, and ash is the inorganic material that is present, like calcium salts or any other material other than fiber. Those are called ash in the technological terms.
But ash is different from clinker. Clinker is a very hard crystalline bluish green mass. Okay, ash is a little bit different from clinker. Clinker is formed in the boiler furnace, and that has got certain accountability in mass balance. Okay. Second issue.
That will come when we are discussing about the boiler. The mass balance of boiler, the ash that we consider in the mass balance of boiler, that itself will be inclusive of the clinker.
You are including that clinker into ash. Okay.
It is not included.
Okay.
This ash is different from that ash.
Okay, in modern industries, okay, in heat balance, we should certainly calculate in calories in metric system. You have mentioned the megajoules. Joules and BTU, British thermal units, they were used in heat balance in British era. Ever since the metric system had come into practice after 1960, now we should use the calories and kilocalories instead of joules, because 1 joule is equal to 4.123 calories. So that is a little bit cumbersome in calculations. Calories and kilocalories will be very easy for talking about heat balance. These are my two observations. Thank you very much. I now request the chairman to felicitate Mr. Athawale, speaker.
Mr. Athawale sir has done excellent exercise. It is a pictorial view of the sugar factory. Calculations and assumptions put on the paper. It is very useful to the gathering in the sugar industry.
Thank you very much, Athawale sir. My submission here is, it's a really ideal paper, ideal blocks. I think if anybody is interested in it, it can be provided by soft copies to individuals, provided they have an interest. And this is more important for the beginners, for the middle, and for the top level also, technocrats I'm talking about, because this is in-depth calculations of the subject. Thank you.
Now, there is also an Excel sheet program that I have made for this. Can you show that?
Sir, that
I mean,
it can be shared.
no, it has been saved. It can be just shown if you want it.
Okay.
Anyway, I mean, that is the basis of calculation, that Excel sheet program, so that you can vary the values of inputs and other things, and you will get the output automatically. If that will be available with the DSTA if anybody wants it. Thank you.
Thanks to the speaker Athawale.